Okay, hello everyone. There's always this nice suspense before a talk starts, so what it's going to be about. I think this talk is actually a great continuation of some work that Brian started today when he talked about making Kubernetes easier, and it should just be, I'm the developer here. Dear platform, take my application and run, deploy, and manage it. Just out of a coincidence, Brian is also co-chair of the SIG app delivery. With me here today is Harry, and my name is Alois. Just out of curiosity, who was at our intro session yesterday? Okay, that's almost half of the people, so we didn't scare you away. That's amazing. So today will be more of an interactive session where Harry will walk us, together with myself, obviously, will walk us through that reference model in detail. And really, if you have any questions, feel free to ask them. If you have any opinions, feel free to share them as well, like we have a mic here, so we can get you involved in here and have a discussion. So feel free to get started. But now let's really dive into this reference model for application definition. This was one of the first outputs really from the work that the SIG has been doing more or less as a preparation for more future work to provide a structured version, which eventually will then also lead into a landscape for cloud-native application delivery. And with this, I'd like to pass over to Harry. And by the way, if the thing down here breaks down, it's not us, it's just squeaking all the time. So we're risking our life to present to you today.
Thank you, Alois. Can you hear me? Right? Okay. No?
No, I think you have to turn it on. I think you have to turn it on. You're off.
Oh, here. Okay, should work. So my name is Lee, you can call me Hari, and I'm from Alibaba. So let's begin. And if you take a look at it, the extensive landscape about application and management in today's landscape, you will find, okay, there are so many projects here. I just list some of them. And they are categorized as two parts. And the first part is so-called application definition. And the second part is categorized as CI and CD. It makes sense to some extent, but if you take a closer look into several projects in this landscape, you will find something interesting. So I will take Helm as an example. I know a lot of people are using it.
So who's using Helm here, maybe?
Should be everyone. It's cool. So yeah, Helm is categorized as application definition in CNCF landscape. It's true because Helm actually gives you a description for application, including metadata about the application, which is defined in charts YAML. For example, the name is maintainers, the link to its docs, things like that. And also, Helm gives you the ability to tracking resources composed this application, right? So if you take a look at the templates files in Helm charts, you'll find, okay, all the things you need to run your application, including the deployment description, services description, maybe persistent volume description are all there, right? So that's how you check your resources you need to run application. And also you can also be able to define the dependencies in the chart file. So you can, okay, say I want to rely on some other charts, that's fine. But if you take a closer look at Helm, you will find something more interesting because it has several functionalities which maybe not belonging to application definition. For example, it actually provides you functionality like package management. That's why you can search and download the charts from the Helm hub, right? Because it's stored somewhere. And also to give you ability to do parameter and configuration. For example, Helm templating, right? It gives the ability to configure your Helm charts to different environments. So if you take a closer look at Helm and other functionalities, you'll find something more interesting, such as release management, because Helm can upgrade your application, can roll back your application. And it's even give you some features like application management hooks. So you can add annotation to your YAML files to say, okay, I want to do something before or after the installation. The question is, are they all part of the application definition? This is actually a very common question in today's SIG application delivery because people like me or you are not very clear about what a project is really about. Here we have three projects, Helm, Customize, and KubeCon. We know they can all do things around your YAML files, but the question is, are they all application definitions? So that's why we want to try to figure out a better answer for this question. What is a project really about? In SIG application delivery, we began to proposing this kind of, we call the model of application delivery to you guys. because it's trying to classify the typical topics in this SIG or in this field into well-defined definitions and models in this diagram. I will walk through this diagram one by one. So let's begin from the topic 1. Please note that we have topic 1 and topic 1.5 because they are very closely related, so we define it like this. So first thing is application definition. It's about Helm, right? So what is that? The application definition is essentially the answer for what to run, right? Your YAML files, your configuration, they are all answer to this question. And in real practices, the application definition are mostly expressed as application descriptor or application model. So what are they? What's the difference? Let's talk about the application descriptor. The description of the application normally including 2 parts. The first part is your metadata for application, which I have shown you by using Helm, right? Including the maintainers, the name, description of application, regardless of its running or not. And the second part is it should give you the capability to tracking all the resources compose the application. That also means if I have an application descriptor, then I should be able to deploy the application by using that YAML file or that descriptor to any environments, right? Because it should be a description of your whole application, all of the resources needed. But speaking of that, it's not so easy. Your application definition or your application description may be simple like this, but the real resources you need to run your application may be very complicated. For example, in Kubernetes, your application maybe needs a lot of Kubernetes resources like services, like CRDs, ingress, SOB, RBAC rules, images, PV, persistent volumes. So all of these resources are part of your application definition. It should be, because if you want to run an application in the cluster, in any cluster, you need to define all of these resources very well. So how can you do that? That's why in real world, application descriptor could be very complicated. I will give you 2 examples. The first one is Helm. Helm is essentially composed by several parts. The first part is application metadata. To give you things I have talked before, like what's the application, what is its functionality, who is the maintainer, right? But also, it provides you a bunch of templating files, which is essentially how it defines what Kubernetes resource you need to run an application. And I don't need to mention it also gives you capabilities to define, okay, what's these charts depending on the others. That's how Helm is handling the application definition for you. It's trying to give you a self-contained application definition by using a chart for application, so you can deploy these charts to any cluster as you will. The second example I'm listing here is the application CRD, which is proposed in Kubernetes SIG application. And this is a little bit similar to Helm. It also gives you application metadata here in this place. The difference is this application metadata file also defines what is the Kubernetes resources I need to run for this application. For example, in this picture, it shows that my application needs to use 1 service and 1 stateful set. So this is actually a reference to the real Kubernetes resources you need to deploy in your Kubernetes cluster. So this is how application CRD works. Well, this is application descriptor. They are actually, you can see as a metadata and give you some means to tracking your resources, right? But what is application model? Essentially, they are quite similar to application descriptor. The only thing the model added to you is a specification for you to define all of the information above, how to describe your application metadata, how to define your resource dependencies. So they just add just one more thing to your application descriptor. One of the earliest application model I know is a serverless application model, SAM, which is proposed by AWS, I think in 2016. So its YAML files are very simple. It just gives you a specification or schema for you to define, okay, I want to deploy a hello world application. And the type of this application is, for example, in this diagram, it's a serverless function on AWS. And then you should define your properties to run your application. That's all. And when you deliver this YAML file to AWS platform, it will actually provision the real resource you need to run the application. In this case, is the AWS Lambda function, which named Hello World, and the corresponding API gateway, so you can use your application, right? So this is SAM. But with this kind of application model, you can do something more interesting. For example, in AWS, you can upload your SAM YAML file to some kind of storage. So other people can download the YAML file and reproduce the application in their own environment, in their own AWS cluster, just like what you can do in your cluster. And another application model is Open Application Model, OAM, which is quite new. So it's quite similar to SAM, but the only difference is here. So OAM, it actually provides two different API states to different users. For developer, it will be responsible for them to define the components YAML file, which is exactly how to describe what to run. And for the application operators, however, OAM provides them with another API state which named trait. It's useful to define the operational capabilities like how to scale, how to scale in and scale out, how to do auto-scaling, how to do ingress. So as a user as a deployer of the application, you just need to combine those concepts together by using application configuration. So this YAML file is actually the application metadata file for the OAM application. So you can just deliver this YAML file to your Kubernetes, and Kubernetes will be responsible for provisioning the deployment, the HPA you need in this application. So this project is pretty new, so if you have any questions, you can ask the Microsoft guys over there. They have a really nice t-shirt for you. Okay. So let's go to the next topic. Now we have application descriptor, right? But the question is, how can I use the same application descriptor in different environments? For example, I want to have only one replica in testing environment, but I want to have 3 replicas in production environment. How can I do that? That's why you need Helm or something like this. There are 3 ways for now for you to configure the YAML files. The first is, of course, templating, which is widely used by Helm. It's very easy to use, but from my opinion, it actually breaks a little bit the integrity of the YAML files because essentially your YAML files are not YAML anymore. It's actually templating files. You don't know the real value of these templating files unless you have rendered this YAML file, right? And that's why there is another project which is named Customize. It uses the overlay technology for you to configure the YAML files. So essentially, you have base YAML and a patch YAML. So it helps you to keep the integrity of YAML files because you know exactly what's the value of replicas, for example, in base YAML file as well as in patch YAML file. And you can store them in Git or something like that. That's why we say it's pretty GitOps friendly. But it actually gives you a higher bar to learn to use this kind of YAML files because it's not essentially how we think in human mind. Human mind cannot do patch or merge. We are not a Git server, right? And the third part for do that is DSL. Essentially, there are programming languages. For example, JSON-net, KSON-net, and Etherpad. They're very powerful because now you can write program to do whatever you want, right? There's no YAML files anymore. You don't need to be a YAML file engineer to handle Kubernetes anymore. But it gives you the highest learning curve because you essentially need to learn another language, right? So this is the difference between these 3 approaches. But there's one more thing I want to add is a very interesting project which is named Sheep. It is actually using the Customize to modify the YAML files of Helm charts. So you can use overlay to change the values in your Helm charts. It's very interesting because it tries to combine the advantages of both Helm charts as well as the Customize. It's very interesting. You can take a look. Okay, so let's go to the application packaging. Now we have descriptors or models, and we have abilities to customize them, right? So the last thing is how we distribute these descriptors in different environments. It's very simple and very straightforward, so you can just use a zip file to do that, right? But also you can use some standard registry, for example, the OCI artifacts to package your applications. And CNAP is one of the typical examples for you to do that, but you can also use Docker image. You can, of course, use Helm charts. The Helm is what I need to highlight here because it's already built an ecosystem for you. You have Helm Hub, you have Charts Museum, you can build whatever you want by set up your own Helm Hub in your own environment. So that's why I list here separately. Okay, so here's a checkpoint. Now we have several projects. We have learned about the topic 1 and topic 1 and 5. So what's the difference of this project? Let's answer this question. We have Helm, Customize, KSON-net, and OAM, and SAM. So you can see, now we can figure out, okay, what are these projects are really about? For example, Helm actually provides you functionalities including both application descriptor as well as application packaging. And of course, it gives you ability to do application parametering and configuration. Wow, it's cool. But for Customize and KSON-net, it only focuses on how to do application parametering and configuration. So this is where it has a little bit overlap with Helm. But they do not have overlap regarding to the application definition. Customize and KSON-net do not care about what you write in your YAML file. They do not care about what you define in YAML file. That's the difference here. But for OM and SAM or other application models, they only care about how to provide you with specification for you to define your descriptor. That's why it only cares about the application model. It do not care about how you modify YAML files. So you can see the difference here. That's why we say this model, application model in the SIG may help you to define, okay, what is this project really about? Okay, let's move to the next topic. The next topic is about application deploy and rollout. It's very important in the real world because you may want to deploy or you may want to upgrade or roll to application without breaking your end user. So I will let Alois to talk about this part because he is really expert in this place. Okay, we can start from a real world typical CI/CD pipeline here.
Yeah, so what we have done so far we have more or less defined what our application looks like, and we have defined a way how we can modify it for different environments and different deployments. One deployment might actually be deployment on my cluster, deployment on your cluster, so forth, but also deployment across different stages. I think the customization problem and the parameterization problems immediately occurs once you deploy it across multiple stages and how you can roll it out. So when we talk about application deployment from a very simple point of view, I think the easiest way we can obviously deploy applications is just applying YAML files using kubectl. I think that's this is a really scary up here. Yeah. The easiest way, that's more or less the easiest way, or we can then use, for example, Helm to do it. But what we really want to do is really, like this typical software delivery model here, we write our code, we put it into version control, run our tests, and then we get our image repo. Technically, we need a bit more than an image repo because just knowing where our container image resides doesn't really tell us anything what to do with it. So on top, we need like all this application description, all this parameterization, and our deployment steps also need to understand how to modify this for dedicated environments. So you see you get this very strong dependency between how I define my application, how my deployment and rollout strategy can tie into this. And then obviously we also have the orchestrator. And guess what? The input is that YAML file. Oops, yeah. The key here, however, is what we want to do. This is actually the first time where we're taking whatever we have as an application definition and translating it into platform primitives that we are then able to execute, which might be deployments, services, if you have meshes, these type of configurations. And we keep them running until they're terminated. So usually this is actually composed by a number of actions. And on top you see an example here how Spinnaker is doing it. Obviously this is I give it this very simple example, which is more or less a kubectl apply. Obviously nobody is deploying workloads just by doing kubectl apply. Well, you might do it in the very beginning, but you realize you have to do more around it, so you have to build this delivery workflow. First of all, it might go wrong, so you have to do something about it. Secondly, you have to automate it, especially if you want to scale. And last but not least, we have cloud-native mechanisms like blue-green deployments, canary deployments, and other things, where we also want to take actions if they don't work as designed here. So on top, you see this workflow here where we first find the image, then deploy it in a canary mode, then do either manual approval or automatic approval, then deploy it to the next stage, and so forth. So a lot of this is usually driven by Git. So there were a couple talks here, obviously on GitHub, on GitOps, which actually is yet another repository where we keep application configuration. The difference here is obviously the configuration we actually keep in Git is not the application definition per se, but already the application definition where all these templates have been replaced with an actual environment. So the idea is I can restore my entire environment from that configuration, which I have in my Git repository. And we have this well-known process here, which we have more or less by having Git review, approve, merge, rollback, and all of these actions, which takes us to GitOps. There's obviously two styles how this can be done. And for all of you who haven't heard the word YAML quite often enough today, this is usually also where we have pipeline definitions, which happens to be in YAML as well. This then again massively depends on the tool, and we start to encode a lot of how we apply these different things across the pipelines. There's projects like Tecton, Argo Workflow, Spinnaker, and others that actually follow this paradigm. There's an alternative paradigm from another project called Captain that use it in an event-based mechanism. So instead of defining the pipeline, you define lifecycle events, and you have tools jump into these lifecycle events and then provide the proper transformational actions. So Another example here is what we put in Flagger as an example. So you can actually define your rollout strategies. And this is also something where at app delivery, CGAP delivery, we want to look at. We all talk about what a blue-green deployment is or what a canary release is, and we might have some agreement on what it is. But actually, this is kind of like secret knowledge if you look at also a lot of the things that happen in the application definition. Because we have defined how to deploy an application, but we have never specified, can this application actually be deployed in a blue-green mode? It should be, if it's a cloud-native application, we should be able to do it, but we have never specified it. Can we actually roll it back? And if we roll it back, are there maybe some dependencies or some orders of stuff that how the things have to be rolled back? So there you see suddenly there is this overlap in our deployment processes depending on the application delivery and some knowledge that is actually only encoded in our rollout process that wasn't even be part of this. So one example here is obviously using something like Flagger. And just to make it more complex, we don't only have to modify the deployed entities per se. Once we start to use service meshes, we have to configure a number of other components in there as well. You put it on the side here. SMI would actually be super helpful because then we are suddenly no longer dependent on the underlying service mesh, but we could have a higher level abstraction in here on how to do it. And then obviously we have Kubernetes as the controller that's running it. And here's an example of how Flagger is handling this and other tools out there. So again, what you see here is more code. Like here you have the reference on top for the workload that you're running, and the lower part actually contains your rollout strategy, which again is a different file, even in this case stored again in a different tool. So it's completely separate from how we handle the application definition piece. This is your fun fact, so I'll pass over to you on this one.
So now we have learned topic 1 and topic 2, and we'll find some fun facts if we take a closer look to Helm again. So Helm actually gives you some functionality that as we mentioned, like upgrade, history rollback, and the lifecycle hook, right? So these functionalities are more fits to the topic 2 because it cares about the application lifecycle as a whole instance. It's not part of the application definition. And also, we observed that with Helm 3 have released, the project is trying to now focus on the topic 1 and topic 1.5 more. So I think it's a good news. Well, let's go to the next topic, which is topic 3. It's about workload instance automation and operation. So the workloads in Kubernetes, including many things like deployments, default set, daemon set, job. These are actually all the topics in Kubernetes application. But it's also including some other things like operator, right? Operator is essentially a customized controller with domain knowledge of the software. And it's also including other projects like OpenCruise. It's actually a bunch of customized controller for you to for example, the advanced stateful set, advanced daemon set, things like that. But you may ask, what is the workload instances, right? So the workload instance is just part in Kubernetes world. But you should know that it can be something else. It could be a function, or it could be a virtual machine in some other cases. So just one example, if you have a Kubernetes deployment with replicas equals to 3, you basically have 3 workload instances in the real world. They are identical to each other. But you may also ask another question, so what's the difference between topic 2 and topic 3? So it's very actually straightforward because topic 2 focuses on application level operations like blue-green deploy, canary deploy, but topic 3 focuses on the pod level, the workload instances level, like how to scale in the pods, how to scale out the pods, how to scale pods with a certain strategy like max available stuff. So another fun fact here is, I don't know if you guys heard about the Rollout project. It claimed itself as name something like advanced deployment, but it's not a deployment. It's a topic 2 project because it focuses mostly on the application level management, including blue-green deploy, canary deploy, and it uses replica set from Kubernetes to handle the workload instance level controller, which is topic 3. So that's why we can see it is actually a typical topic 2 project. Okay, you may also ask the question, why we decouple topic 2 and 3? Why just we don't make them together, right? For example, Rollout, Flagger, they all work together, right? So the question is, can we do Flagger canary deployment for operator-based applications, right? With the same spec file here. We just change the workload target array to my operator. Can this work? I don't think so, but it should work. So the key point here is that today applications may be running by deployment controller, but it could be possible by stateful set or even operator. So how can we route these kind of applications by using the same strategy like Canary deployment for operator-based applications? It should work. So we don't think it's good if we vendor lock our developers by using our topic 2 capabilities. We don't have to do that. We should let the developers have their own freedom to choose whatever workloads they want. That's the key point of why we want to decouple topic 2 with topic 3 in this model of this SIG. Okay. So let's do some summary, and this is actually another interesting question. So what is the relationship between this model to multi-cloud? So I will use a cross-plan project as an example here. After deep diving into this project a little bit, we found that the multi-cloud projects are mostly handling this part, the topic 1 and topic 1.5. For example, I list how cross-plan describes its application here. Essentially, it brings out its own version of application definition. So you can claim, okay, this is the YAML files I want to deploy, this is the CRDs I want to deploy, and this is the application metadata for this software. So that's all. And then it provides you with the topic 1.5 capability for you to package them as an application stack. And then cross-plan itself is more like a multi-cloud scheduler. So it schedules the application to the corresponding cluster by using certain strategies. That's all. That's the multi-cloud project we are looking at today. So they are actually defining application definitions for you, and as well as application packaging for you, and then deliver this software by using this definition and packaging to multi-cloud and multi-cluster by using its own strategy. So this is a relationship between these kind of things. Okay. So now, if you guys go to you went to the introduction station yesterday, we actually have a server for you. So we have the same server today here. So guys can just scan the barcode here to do the survey.
Yeah, so we will just ask you which tools you're using. And maybe to conclude that session, you might have the feeling, okay, this is like really complicated. And the truth is, yes, it is really complicated. And people are doing a lot of things. So what was the value of really creating the application definition model here? First of all, we wanted to put tools into a specific bucket, and we wanted to have like more unified language when we talk about application definition, when we talk about deployment and rollout strategies and these kind of things. I think the other advantage for all of you, so I usually like to end my talks, is like, what are you going to do on Monday morning? Hopefully you get a good cup of coffee in the morning or tea, whatever you prefer. I think what this model also helps us to do when we define our own processes. So very often, especially when people get started working with a platform like Kubernetes, they're at some point super happy that this thing finally works. Okay, first of all, you're super happy that your YAML files finally work and you can deploy them without any errors. Then you move to a Helm chart, and it is super helpful that your Helm chart works. And then you're happy that the parameterization works and that you can do a blue-green deployment, and then you think everything is great. So you just build on top of all of these individual entities. But I think you have never really thought through what you have been building. And what this model helps you is maybe to separate out which decisions, whether they were deliberate or not deliberate, you have taken along that way, and whether there's actually a clear separation or certain things like replacing parameters for the application packaging parts are happening as part of your deployment strategy. So it can help you to really look and validate what you're working on right now, and like really reevaluate whether the choices and the separation is how you actually want it to be with what you might have today, which just makes you very happy that it's actually working and running. And you might also then say, well, actually, we're not that good at that point, or this is like not really defined, or even in the projects and services we're using today, we have like 3 different ways to doing certain things. For us as the SIG, this is also an input on how you can use different tools and work on best practices. So this is also an active call for the people who are here, because as you're obviously interested in this, if you have figured out that you had a great idea how to do certain things, you're more than welcome, obviously, to participate in the work of the SIG, and also have your best practices to share. Feel free to do so. In this survey, we just collect the number of tools. It is like an initial input on what will eventually go into a landscape. It's not going to be the final one, obviously, but just for us to see which tools people are using out there, instead of having you raise your hands constantly and shouting tools at you. So I think we have a couple minutes left here. So are there any questions? So we also want to make this interactive at this point. So questions, comments that you want to bring up? Yeah, sure. I'll walk down here and try to not break the thing down.
Thanks. So I really appreciate that somebody's actually looking at this, because I'm finding that there's not enough emphasis put on this particular problem. One thing I wanted to ask is around Helm, and you've identified several areas that Helm plays in, and one could say that it kind of overreaches into certain areas. In particular, when it comes to things like GitOps, if somebody wants to implement a GitOps delivery model, Helm generally has packaging, so it has its own versioning. You generally need to publish charts. In a GitOps model, you're supposed to use Git and therefore use commits. And so, when you draw those boxes and try to separate things out, how do you deal with those types of things where tools, in particular Helm, I would say, is probably guilty of this more than other tools, kind of overreaches the boundaries between packaging, bundling, and also, I would say, so Helm, especially when you're doing, air-gap type of deployments, you need more than Helm, and you need to version that as well. And so what is the actual general approach with respect to existing tooling and trying to align things in a way that makes it cohesive going forward?
Yeah, there's a couple of questions, and I thought you might want to get back on the Helm piece.
Yeah.
Maybe before we talk about Helm, and this wasn't supposed to be a session against Helm, but overall I think that not necessarily every tool needs to play in one area. This is just to create the awareness. Maybe we figure out that certain areas are so closely connected that we shouldn't look at them independently per se, and also have like tools being closer together. But I'll obviously pass over to you, Matt, for Helm.
Hi, if you don't know, I'm one of the Helm maintainers. So this is one of the things we've thought a lot about. And so at least in my view, it's not so much about breaking it down into parts of the model. Some of this may seem a little bit, the Unix model and piping tools together to solve problems, right? But what a lot of folks need is something that's a complete solution that does something, right? They don't want to have to know how to use a bunch of things and pipe the right things together. They want to just have one thing that works simply. And Helm's a package manager the same way apt and Yum and Homebrew are, and there's certain features you need in that. And it's going to overlap certain areas, because what it does is it takes a certain amount of complexity that a small number of people know how to deal with, and then it allows people who don't know that complexity to use it, like installing Postgres on Ubuntu, right? Apt lets you not know where the configuration files need to be and the layouts for all of those, and yet you can just run it and start using it very simply and quickly. And you can even do it in a production manner, right? And that's the idea. So it does overlap into some of those areas. And so it doesn't map perfectly to all of these things, because it's solving a kind of a usability, a user combined problem. And there's different things, whether you're doing ops, whether you're packaging and sharing things, whether you're using GitOps or whether you're using a different model, because there's a bunch of models people use. And you're going to use different tool chains. And I think figuring that out and coming up with good solutions is going to come up with lots of different stuff. And like you brought up air-gapped. Helm isn't great for air-gapped, which is why you see other package management solutions coming along, like CNAB, which deals with that, and it was designed specifically with things like air-gapped in mind. So I think when you start looking at what a problem is and how do you make a holistic solution, it's a little bit different than the tools to piece together in a Unix philosophy, but some people want both, and so having all of it is probably useful. At least that's my take. I'm happy to talk more about it if somebody wants to after.
Thank you, Matt.
Did you have a question? Yeah. While I'm working over there, so by the way, there will be also as part of SIG app delivery, there was a lot of requests also yesterday about air-gapped systems, so more and more people are approaching us. So we will have a dedicated discussion about air-gapped systems specifically within one of the next meetings. And I think we will be kicked out pretty soon, but I still want to give a chance to ask a question.
So in that same vein, though, there's you don't check your built containers into Git to do your Git ops. And Helm, to some extent, a Helm package is a decoupling of the packager of the software and the actual deployment thereof. And so the values that you do when creating a release, that's the thing you do in GitOps. And the development of the Helm chart is a separate thing.
Okay, one more. And I will be continuing until we get kicked out here, don't worry. They will kick us out. So maybe this is the last one and people can also still hang around. Why am I using two mics here?
So what I'm missing in the application definition is service level indicators and objectives. So you need a way to check whether your application is really healthy. And also, if your application is in production, you need some way to trigger remediation action. So this should also go along with the application. And this is not managed by Helm yet. So I'm missing here some input.
Yeah, I think it's a good, as Brian brought it up in the keynote today, it's actually right, we don't talk anything yet about from the operations perspective, how something should be managed, like also health endpoints and so forth, so we forget about this one.
Yeah,
I think that's good input.
Yeah, so this part is, I think, currently missing from our model, so we are thinking about that because it's very complicated in the real world. There are a lot of projects related to that, but all of them are not focused on that part by themselves. So but think about, okay, what is a real model for this application definition? So right now we are more talking about the application descriptor actually, or application metadata. But for the operational part, there's no currently a very well-defined model for that. I have to admit. So maybe that will be our future work.
Yeah, I think that's a very good discussion, but there's already people in the back, I think, who want to get in here for the next session. So obviously you're fine to continue offline. Offline meaning there's an app delivery GitHub repository, there's the mailing list, there's also the Slack channel, and there are bi-weekly meetings happening where we are all working together. Thanks, everyone.